All right, this is Chapter 4 Summary Notes. This video will be on electron configurations. We left off looking at the chart that you see on your screen, showing the main levels of energy that are on the periodic table. Okay, main levels of energy, the sublevels at each main level, the type of sublevel that's there, and S, P, D, and F orbitals, how many orbitals there are on a sublevel, and the maximum number of electrons that each sublevel can hold. And we made a remark that said no matter what orbital, you can only have 2 electrons per orbital, per single orbital. All right, and that's important. Then we answered a few questions. Now these electrons, there is a method by which we're going to take a look at on how to show the distribution of the electrons across the main levels and sublevels that are there. All right, and this is known as electron configurations. All right, and you see what's here for carbon. Carbon is element number 6 on the periodic table. Okay, atomic number 6, which means it has 6 protons and 6 electrons, and we answered a question like that in a chart form. All right, so that when we take a look at this electron configuration that's here, we want to identify the parts. All right, and the parts that we see are the main level numbers. Okay, those are the main level numbers. And thus we have the sublevels that are there at each main level. Okay, so the S's, the 2 S's, and the 1 P. And then what's really cool about this is that if you add up all the electrons, 2, 4, 6, that means you have 6 electrons. So if you know the number of protons, which you can find by looking at the periodic table, then you know the number of electrons. And the little sentence under that says you read this as 1 S2, 2 S2, 2 P2. And that's how you read an electron configuration. All right, now there's one other way that we can model spin within an orbital, and that's the orbital diagram that we alluded to when we showed you. All right, close your eyes a second because I'm going to go all the way up to the top where we saw the boxes. All right, so open them back up. Here's where we were looking at another way to show the types of sublevels within a main level by using boxes. All right, so we have 1 box for the S orbital, 3 connecting boxes for the 3p orbitals, 5 for the D, and 7 for the F. All right, now close your eyes as I spin back down to where we were. Okay, but you're going to practice and practice how to do electron configurations showing the spin that's distributed among the electrons. All right, so if we do this one for carbon, all right, the way we do this, we know that the S sublevel is going to be filled up, and we show opposite spin by doing one down and 1 up. All right, same thing with 2s, 1 down and 1 up. All right, the P sublevel has 2 more electrons. All right, and these electrons get distributed across the orbitals before you go back and pair them up. That means when we distribute these electrons, you put 1 in the first box and 1 in the second box, and they will have what's called parallel spin. Okay, that's known as parallel spin for the p orbitals because it's stable that way. All right, it's more stable that way than any other arrangement that there is. Okay, so please remember that to distribute any of the electrons, 1 in a box if you have connecting boxes for the B, the P, the D, or the F. You want to do that. All right, so I'm going to erase this one so we can answer some of these questions and work with the same outline up here. Okay, we want to make sure we do parallel spins. All right, it says let's do the electron configuration and the orbital diagram for nitrogen. All right, nitrogen is still on the 2nd row. All right, so let's see how many protons nitrogen has, or the atomic number. All right, the atomic number is 7. All right, so that means we have 7 protons. I keep wanting to put a 0 there, and I know that's not right. All right, 7 protons. It also means we have 7 electrons. All right, number of protons equal the number of electrons. All right, so we have 7 electrons to distribute. All right, so the first two boxes are going to look just like carbon because they enter electrons on the lowest energy levels first. All right, now we have three more. Now, if you remember what we did for carbon, you'll remember to do the same thing for nitrogen. Okay, one in each box, parallel spin. We read this as 1s2, 2s2, 2p3. Okay. All right, so let's write the abbreviated configuration for arsenic. All right, find arsenic on the periodic table. It is one of the metalloids on the staircase, touching the staircase. It's element number 33. Okay, it's element number 33. All right, so stop the video a moment and try that one. See how far you can take it, and then come back. All right, so let's get started. We have 33 electrons to take care of. I'm going to write out the full configuration and then we'll abbreviate it. I think that would be the easiest thing to do. So we have 33 electrons. So we start 1s2, 2s2, 2p6. That's as far as we've gone so far with these other configurations. But now let's go down to the next block, which is 3s2, and all the way across to the other side, 3p6, 4s2. Oh, look at that. 4s2 fills in before 3d10. All right, and then we come over to where arsenic is located, and it's in the same column as nitrogen. So guess what happens? It's going to look just like nitrogen's ending configuration. Here's our highest main level electrons here. Okay. All right, and then if we're going to use the abbreviation, all right, we're going to take all of this till we get up to a noble gas configuration, which is all the way up to the third row. And this all represents argon. So I put brackets around argon and then I continue. Okay, so when I get done, what's interesting about this is that the highest main level electrons here tell me the row and the group number that I can find arsenic, where I can find arsenic. All right, it's on row 4 and it's in group 5A or 15. All right, so you can work backwards and do that. All right, I'm going to skip this because we're going to come back to it in just a few minutes in another question. All right, so the way I did the electron configuration here was by using the blocks that are on the periodic table. All right, elements in these first two blocks here, the alkali and alkaline earth elements, fill electrons in on their s sublevels to finish them off. Okay, 1s1 is hydrogen, lithium ends in 2s1, sodium ends in 3s1, and so on down the column. All right, helium should be over here. Okay, but we know we put it over here because of its noble gas characteristics, but it really belongs in the 1s block as far as the electrons are concerned. All right, because these all end in s2. All right, beryllium, magnesium, calcium, they all end in s2, just one period higher for each. All right, but when we get down here to this fourth row, notice what happens. The 4s electrons fill in first, because they're spherical in nature, very easy amount of energy to maintain that shape versus that 3d orbital. All right, so the 4s electron takes a little less energy than the d level electrons do, so they fill in first. All right, so that's why this is called the d block here, and why this number in front of the d is 3 rather than a 4. Okay? It takes a little bit less energy for that 4s to fill in than it does 3d. Okay? And then when we came over to the other side, arsenic is located right here. Let me do that in red or purple. All right, arsenic's located right here. And it's the third block over in the p block. So every set of 2 blocks over here represents one of those p orbitals. And if you count your blocks in the d section, there's 10. And if you count the blocks across in the F block, there are 14. All right, because 7 orbitals for F block, 14 electrons. 5 orbitals in the d block, 10 electrons. 3 orbitals in the p block, 6 electrons. Okay. All right, so here's some problems here to do. I know this one's running a little bit longer than I'd like, but we're going to get through it. All right, so stay with me because this is a really an important topic to get under your belt. All right, so remember what I said about you can add up these electrons, and if electrons equal protons, then you know what element it is. Okay, so let's do that. If we take a look here, there's 10, 2, 4, 6 more make 10, and then there's another 10 here, so that's 20, and then 7 more makes element 27, all right, or 27 electrons that we distributed. All right, but it's also equal to 4s1, 4s2, 1, 2, 3, 4, 5, 6, 7. This is the 7th block over, all right, which is 27 electrons, so it is element cobalt. We're in the D block. Okay, when we get done. All right, but the highest main level electron is this 4s. All right, this next one is not as long of an electron configuration. It ends in 3s2, so I can count down 1, 2, 3. I have to be here, but I need to be over one more block because it's s2. So that element is magnesium. All right, because it's 12 electrons, so it's magnesium. And we're in the S block. Okay. All right, so the last two elements here that we're going to consider, iodine. All right, if we're just going to do the abbreviated version of iodine, find the period and column that it's in. All right, it's on row 5. All right, so if it's on row 5, I know 5s2, and I know that's over there in the P block, 5p7, 5p, not 7, but 5p5. So 2 and 5 is 7. All right, remember it's the combination of the 2 and the 5 that equal the group number for your representative elements. Okay. All right, so it's the abbreviated electron configuration. So I need to include the noble gas that comes before it. So that's xenon. All right, we're still missing some things in the middle here. All right, and that's what I want to take a look at next. Okay, so if I'm doing iodine, the 4D block is what's missing. So I need to include that, 4D10. Okay, remember you go down one number for the D block to fill that one in. But again, the highest main level electrons are the 5s2, 5p5. Okay. All right, and then the very last thing that we're going to do is copper and chromium. I'm going to model chromium. It's one of the exceptions on the periodic table as to how its last amount of electrons fill in. All right, chromium is element number, all right, it's atomic number 24. All right, so I've kind of made it a shiny gray because chromium is out there shining up lots of different things because it's such a stable metal. All right, and it's stable because of the way its electron configuration fills in. All right, so I'm going to do the whole thing, 1s2, 2s2, 2p6, that takes care of 10. All right, 3s2, 3p6, 4s2, that takes care of another 10, so that's 20, and then I can count across 4 blocks, 3d, 4. All right, this is known as the expected electron configuration because that's by using the periodic table to help you do that. Expected configuration. All right, what really happens here with this last 2, and I'm going to do it in a different color and I'm going to move over. Instead of it doing this, it does this. And I'll do the orbital boxes as well. All right, so it does this, only one, and then 1, 1, 1, 1, 1. All right, why does it do it like that? Because this arrangement is very stable. It's half-filled sublevels are stable. All right, and modeled chromium, you can think about how copper does this, and see if you can come up with the configure stadium. I've got football on my mind. It's Friday. All right, it's stable. Hope your team wins. All right, half filled is stable, and of course, filled sublevels are even more stable. Okay, but that's how to do electron configurations and use the periodic table to do electron configurations. It's so easy to just look at the periodic table and know once you're familiar with the blocks that are there and the numbers that go with the blocks for the rows, 1s, 2, and so on, S block, the D block. The D block is always one number less than the row it's on. The F block is two numbers down from the rows that they're on. In other words, the 6th row actually goes down to 4F. The 7th row goes down to 5F when you fill in for the F sublevels. But it's always S before P, before D, before F as far as energy is concerned. Okay, when we do electron configurations, we are filling in S, then P, then if we get down here to the 4th row, it's 4S, go down 1, 3D, come back up to 4P. If we do the 6th row, 6S2, we come down here and do 4F14, all right, 2 numbers down, 5D10, only 1 number down, and then come back to 6P. The S and P electrons are always your highest main level electrons, and we'll touch on that again in the next video when we talk about valence electrons. All right, that's a long one, and I'm sorry.